everyone, this is lesson 24, session 2. It starts on page 475 of your math workbook. If you haven't done session 1, go back and complete that first and then come back here. In session 2, we are developing our skills with dividing a unit fraction by a whole number. By the end of today's lesson, you should start to feel more comfortable not only dividing a whole number by a fraction, like we covered in session 1, but also dividing a fraction by a whole number. Let's get started. Here's today's warm-up problem. Copy and complete the model to show 1/5 divided by 2. At this point, I'd like you to please pause the video so you can work out the problem and then press play again when you have your solution. All right, let's look at our solution. I see that we have 1/5 divided by 2. What this is really telling us is that we have 1/5 sections and that we are dividing each into 2 parts. And the solution is going to tell us what size each of those parts is. So we already have our diagram divided into 1/5 sections. There's 1, 2, 3, 4, 5. And I'm going to divide each of my 1/5 sections into 2. So divide that one into 2. That one's divided by 2. Divide by 2, divide by 2, and then the last one divided by 2. All right, the solution to this is going to be what size each of these sections is. So I can see that it is now divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections, and so one of these sections is 1/10. So 1/5 divided by 2 is 1/10. Now we noticed that yesterday, when we had the whole number first divided by the fraction, our answers were greater. They were whole numbers. Notice that today, when we have the fraction that comes first, we're getting a smaller fraction. So be mindful of that as we go through today's lesson. Okay, this is the first problem in your book on page 475. Follow along with me as I read. Piper uses 1/6 yard of ribbon to make a border around an equilateral triangle. How long is the piece of ribbon that Piper uses for each side? Now, I see a term in there, equilateral triangle. For the sake of this lesson, please remember that an equilateral triangle is a triangle where all sides are equal. Please pause your video and work the problem solution in your books, and then when you have your solution completed, go ahead and press play. All right, we're going to circle the important information. So our ribbon is 1/6 yard, and we're making a border around an equilateral triangle. So it doesn't actually give us a number, but we know that it is a triangle, so we know that our second number is going to be a 3 because triangles have 3 sides. And then the information that we need to figure out what we're supposed to do is how long is the piece of ribbon that Piper uses for each side. Okay, so if I were to write this out, I would take the total amount of ribbon. So we're going to start with our 1/6, and we are dividing that into 3 sides of the triangle. So our equation looks like this: 1/6 divided by 3. So to use the same model that we used before, let's see if I can do this drawing with my mouse. We have our visual model here, and let's divide that into 6ths. Okay, and then each one of those 6ths is going to be divided into 3 pieces. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and there. Okay. All right, so each of my pieces is divided into 3 different pieces. So to find the solution, I would like to see what one of these sections is. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 pieces now altogether, and so one of these sections represents 1/18. So 1/6 divided by 3 is 1/18. All right, so that's how we could use a visual model to solve that problem. Let's go ahead and look at an algorithm that can help us solve that as well. So we have our 1/6 again, and it's a triangle. So we have our 3. So our equation is going to stay the same. We have 1/6 divided by 3. So if we remember our strategy of keep, change, flip, we keep the 1/6 as is. We change division to multiplication. Turn off my sound there. And then we are going to flip the 3 upside down. Now, if we think about the 3, 3 is the same as 3 over 1, 3 whole numbers. Oops. Erase that part right there. Okay, and so if I flip that upside down, what I would get is 1/3. And then what we did in our previous lesson, learning to multiply fractions, we know we just multiply the numerators 1 times 1, which equals 1, and 6 times 3, which equals 18. So we get the same answer both ways. Okay, we are going to look back over the picture it strategies. The first one is using the diagram, drawing a picture to help understand the problem. Draw a 1-yard length of ribbon, and then draw and label 1/6 yard length. So here is 1/6 of the yard. Divide the 1/6 yard into 3 equal parts, one for each side of the equilateral triangle. So just like we did on the previous slide, we have our 1/6 piece, and we divided that into 3 parts, one for each side of the triangle. And then as you can see, we have the rest of our sixths here as well. There's 2, there's 3, 4, 5, 6. 2, 3, 4, 5. Okay, so there's each of our 1/6 pieces. You can use equations to model the problem as well. Write a division equation. So we have our 1/6 divided by 3. 1/6 is the length of ribbon, and 3 is the number of equal parts. And then our answer, our quotient, is going to be the length of each part. Remember, we keep, change, flip. So our 1/6 stays 1/6. Our multiplication changes to times, and we flip 3 wholes, or 3 over 1, upside down to get 1/3. Now, notice that in your book, they did switch these 2 around. It doesn't matter. Once you have 1/3 and 1/6, it doesn't matter which order you multiply them in, you're still going to get the same answer. So if you write your 1/6 first and your 1/3 second, it's okay, you're still going to get the same thing. We're now on page 477 of your workbooks. Number 1, look at picture it. What does the first diagram show? What whole is being divided? If you want to answer out loud, that's totally fine. That's right. It shows 1 yard divided into 6 sections. Each section is 1/6 of a yard, which is the length of the ribbon that Piper uses. Why does the second diagram show 1/6 yard sections divided into 3 equal parts? The 1/6 yard section of ribbon has to go around 3 sides of the triangle. We know that triangles have 3 sides and that each side has equal length. So that's why we divide by 3. Number 2, look at model it. How does each equation relate to the second diagram in the picture it? Well, the division equation shows that the 1/6 yard of ribbon divided into 3 equal parts, just like in picture it. The multiplication equation shows that you're finding 1/3 of 1/6 of a yard. So if I am writing 1/3 times 1/6, that's the same as writing 1/3 of 1/6. Each part in picture it is 1/3 of 1/6 yard. So number 3, how long is the piece of ribbon Piper uses for each side of the triangle? Each piece of ribbon is 1/18 yards. So number 4, what is 1/6 divided by 1/3? How can you use a multiplication equation different from the one shown in Model It to check that your answer is correct? Well, on a previous slide, we looked at 2 different equations. We had 1/6 times 1/3. We also had 1/3 times 1/6. Look back at your Try It strategies by your classmates and picture it and model it. Which models or strategies do you like best for dividing a unit fraction by a whole number to solve word problems? And then explain your answer. Some of the strategies that we looked at in this video today are drawing a model. We also looked at an algorithm that helps you to convert a division problem into multiplication. You may have other strategies that you talked about with family members or other classmates, or even that you came up with on your own. All right, on page 478, let's apply your thinking to a new problem. Felipe has 1/4 of a pizza. He wants to share it equally with a friend. How much of the original whole pizza will each of them get? Show your work. Go ahead and pause this video. Make sure you're circling the important information that you need to use and underline what you need to figure out. Also, it's really important that you're showing your work. Okay, looking at important information here, he has 1/4 of a pizza and he wants to share it equally with a friend. So if there's Felipe and his friend, how many friends are there? There's 2, because Felipe is 1 and the friend is 1. How much of the whole pizza will each of them get? Show your work. So I'm going to do a couple of different things here. I'm going to start by drawing the pizza. And I know that he has 1/4 of a pizza, so I'm going to divide my pizza into fourths. Okay. And it says he wants to share his 1/4 of the pizza. So this is the amount of pizza that he has, this section right here. And he wants to share that 1/4 of a pizza equally with his friend. And since there are 2 of them, we're going to divide that pizza into 2 parts. So if we look at the size of each of these parts, we see that, and if we would do the rest of them, that makes it easier to count. And if this is the one that Felipe gets, and this is one that his friend gets, what size of a part does each of them get? There's 1, 2, 3, 4, 5, 6, 7, 8. So they each get 1/8. Now, if I were to write this as an equation, I would write 1/4 divided by 2 friends. So the 1/4 is going to stay 1/4, divide changes to multiply, and the 2 is going to get flipped around. We call that the reciprocal. So 2 is actually 2 over 1. So if we flip it, it would be 1 over 2. And then when we multiply numerator by numerator and get 1, denominator by denominator, we get 8 we get the same answer. So that's a great way to show our work. We did it in 2 different ways, and we got the same answer each time. Number 7, Angela uses 1/3 of her rectangular flower garden for roses. She plants equal rectangular areas of red, white, pink, and orange roses in this part of the garden. What fraction of the whole garden has red roses? Draw a model and write a division equation to represent and solve the problem. Okay, once again, pause your video, circle the information that you need to use, and then underline the things that you need to do. There are 2 things, actually there's 3 things that you need to do in this problem. So be careful about that. Information we need to use, there's 1/3 of her rectangular flower garden is roses. She plants equal areas of red, white, pink, and orange roses. So that is 4 kinds of roses. What fraction of the whole garden has red roses? So that is something we need to find out. Draw a model and write a division equation to represent and solve the problem. So we need to figure out what fraction of the whole garden has red roses, and we need to do 2 things to figure that out. The first thing we need to do is draw a model. We also need to write a division equation. So what is the area of her rose garden? It's 1/3 of her garden. And she's dividing that section amongst 4 different colors of roses. So we have 1/3 divided by 4. So if we draw her garden here, this section right here, she's using for roses. Okay, and she's dividing that section into 4 parts because there's 4 different roses. Okay, and if we want to get creative, we can even say this one's red, this one I'm going to leave white. Oh, well, let's see, I can't really find a pink here. Let's use this one. It's not really pink, but that's okay. And orange. There we go. What fraction of the whole garden has red roses? So if each of these sections were divided into the same fractions as this one, 2, 3, 1, 2, 3. How many fraction sections are there altogether? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 12 sections, and one of those sections is red roses. So 1/12 of her garden is roses. So we've drawn a model, check. Okay, writing a division equation. We have this equation here, 1/3 divided by 4. So we're going to keep the 1/3. We're going to multiply, and 4 is the same as 4/1. So we're going to flip it and say 1/4. And 1 times 1 is 1. And 3 times 4 is 12. Awesome, we got the same answer. All right. Number 8, look at problem 7. Which multiplication expressions can be used to represent the situation or check the division equation? So if we look back here, we have 1/3 divided by 4. That's 1/3 times 1/4. Let's see. Does this one work? 1/3 times 1/4 is what we did. Yep, that one works. Okay. 1/12 times 4. Oh, let's see. If I make that into 4 over 1, that would be 4. Oh, how'd that happen? 4/12, which we can divide by 4 and divide by 4 and get 1/3. All right, that one works. This one works because we still have the same number family here. There's our 1/12, which was our answer, which we multiplied by 4, which was our divisor, and we got our dividend, which was 1/3. So we still have the same numbers in an inverse operation. That's why this one works. Okay, 3 times 1/4. Let's look, 3 over 1 times 1/4. That's 3/4. Oh, we never saw anything with 3/4, so that one can't work. All right, 4 times 1/3. So if we have 4 over 1 times 1/3, 4/3. That's the same as 1 and 1/3, so no, that doesn't work. 3 times 4. 3 times 4 is 12. But our answer wasn't 12, it was 1/12. So that one doesn't work either. You should have A and B. Your assignment is to complete the green pages 479 and 480. After you are finished, please take a picture of it or scan it and submit it either on Google Classroom, or you can email it to me at jessica.nash@entheosacademy.org. And I'll see you for session 3.